Welcome and thank you for joining us again for another episode of the Jain Irrigation Training Series. I'm your host, Richard Restuccia, and today we're going to be talking about some real basics of drip irrigation, some basics of just irrigation in general, and that is what emission device should you be using for a particular job. Now, the reason this is so important is, I grow roses. And I always think, for my roses that are on drip, should I be using a emitter line, a 1/4 inch emitter line with 6-inch spacing? What about 12-inch spacing? Or should I be using a shrubbler that puts out 3, 4, or 5 gallons per hour? There's a lot of choices out there. That's just the difference between emitter line and spacing and shrubblers. There's a lot more than that. And it gets very confusing. And one thing is for sure is when you match the right emission device to the plant, you know it right away. You can see the gains in the plant, the health of the plant, the vigor of the plant, much better when you match this correctly. So helping us through this today is Andy Belingheri. He's the National Sales Manager for Jain Irrigation. Andy has a long history of success in the landscape industry. He's a horticulture major from BYU. He worked at Valley Crest companies. Both he managed crews in the field, moved into business development. And now for almost the last 8 years, he's been doing national sales management for Jain Irrigation and continuing his education and a lot of teaching as well for drip irrigation. So when I think about somebody who's really made an impact on the drip irrigation market and more importantly, water conservation, Andy always comes to mind. So Andy, welcome and thank you for joining us today.
Well, it's a pleasure to be here as always, Richard. Thank you.
So Andy, the first question I had about this, and it's kind of an embarrassing question because as I thought more about it, I thought, I don't really know. What is an emission device? How do we even define this?
Yeah, well, that's a great question. Great starting point. It's funny, things that you take for granted, dealing with it every day are like, oh, everybody knows what an emission device is. I touch them, I use them every day, but how to put that in a succinct definition that's very basic. And irrigation devices or emission device is really any device, any apparatus in an irrigation system that applies water. And by a very broad definition, that could be a spray head or a drip emitter or a bubbler or a hose and sprayer, I guess, a device in an irrigation system that applies water.
Yeah, so that's interesting because I think a lot of times I think about it in terms of drip irrigation only. But yeah, a rotor, a spray head, some of these things that really waste water are emission devices also.
Yeah. I'm glad you said that, things that waste water. There's an old story about these turkeys that learned how to fly, right? They went to school, they learned how to fly, and then they walked home. Maybe you've heard that story before. And the moral of the story is, don't be a turkey. So we know there is a better way to apply water, yet we are still using technology that at best is 50 years old. Some of this technology is getting close to 100 years old, and I'm talking about spray irrigation. Now, there may have been a few little advances here and there, but for the most part, there are some very inefficient and widely used irrigation practices. And our topic today, drip irrigation basics, will be the emission device in drip irrigation. But I want to start first, kind of on why drip irrigation versus spray. Why does it matter, right? We hear a lot of stories about drought, and maybe 10-15 minutes from my house is Hoover Dam, and this is a picture of Hoover Dam. This was in 1983 when the spillway was overflowing. It was I think the only time in the history of the dam's operation that spillway was flowing. I remember as a child going out there, and it was an awesome sight, a sight to behold. When people talk about the power of roaring waters, of moving waters, my goodness, if you've been to Niagara Falls, you know how that is. So this is 1983. Lake Mead, Hoover Dam has been in the news a lot lately, but I want to go from 1983 to 2003. And we begin to see why the need for efficiency is driving drip irrigation. The need to have a better way is driving this. So this is 2003, kind of from that same spot. And if you take a look at kind of the ledges and the rocks, some of those geological features here, we jump forward another 10 years to 2013. And when I do this presentation live, this is when I start to get gasps.
Yeah. Yeah,
Okay.
you can see that that tub line is getting really big, that ring.
It is. And you can see kind of in the middle bottom, right above is driving, there's like a little retaining wall. So pay attention to that. And then we go from gasp to moans of pain when we jump the next decade forward. This was August of this year.
Wow.
Yeah. Lake Mead is about 25% capacity, I believe, somewhere in 25-30% capacity right now. And Las Vegas would be right now unable to draw water, drinking water, out of Lake Mead if it weren't for a third straw that they just finished at the beginning of this year that started sucking water. I mean, it was that close. I'm rereading, actually listening this time to Charles Fishman's book, The Great Thirst. Recommend everybody go back and take a look at that and think about water. Rather, it is a national, it is a global issue, but locally, what can we do locally? And locally, I want to talk hyper local at your house, in your HOA, in your realm of influence. We can do something, and we're going to do that with drip irrigation. So as I mentioned earlier, we have this antiquated technology called spray irrigation. It is typically listed at 50 to 55% efficient. That's a best case scenario. I've seen some poorly designed, poorly maintained systems in the field that are probably closer to 35% efficiency. And that's probably not the exception. There's probably more that are in that range than we think.
So, yeah. Andy, help me out here with this definition or this concept, right? So when you say it's efficient, for example, if we have a spray at 50% efficiency or distribution uniformity, and I'm applying 10 gallons of water, what does that mean? How many gallons actually reach the grass?
Hey, Halloween's around the corner, so I'm gonna use some scare tactics here, right? This is the boogeyman jumping out of the closet. Half of it is wasted. At 50% efficiency, half the water you apply is wasted.
So, and when you say wasted, you mean it either runs off, it evaporates, it just doesn't get to the plant.
Doesn't get to the plant. Yeah, overspray, runoff, evaporation. Sometimes it's over application in one spot, under application in others. That gets more into distribution uniformity, some other terms, which may be a topic for a webinar upcoming. But for basics today, spray irrigation at best, half the water is wasted.
So Andy, oftentimes we hear people say, oh, get rid of such and such plant. And what I think they really need to be saying then is, take a look at what you're watering with instead of what you're watering.
I know, and this number varies depending on what part of the country you're in, anywhere from maybe 50% to 70% of the average household water is used outdoors. If you're in the desert, that's going to be higher. If you're in, a coastal or mountain community, it's going to be lower. But if half the water, let's just use half the water we use is used outdoors. And if we're using spray irrigation, half of that water is being wasted right off the top. And this is assuming that other irrigation management practices are being followed, right? Proper scheduling, so forth and so on. Let's just, let's accept that everybody's doing it the right way, which nobody is. But just right off the top, switching from a low efficient spray irrigation, which in my opinion, nobody in their right mind should be pushing or selling this product. Nobody responsible anyway. But just by switching from a low efficient product to a high efficiency product, we can reduce on average our water usage by 25%. That's a huge number. That's a huge number.
Well, right. It's the number many of the states in the West need to reduce by due to the drought that we're experiencing right now.
Yeah. And when we look at drip, I mean, I put up here 90% efficient. I've seen numbers as high as 95, 98% in some of these systems. So those are big improvements.
So in that case, if I'm applying 10 gallons, almost all 10 gallons are getting to the plant.
Yes.
Yeah.
Yeah. And usually that's the case. I mean, on a bad drip system, maybe a gallon is wasted. But again, I've seen 95, 98% efficiency.
Yeah. Okay. Interesting. Yeah. Thanks. And I just want to remind everybody too, I've got the chat open and the Q&A. So if you've got some questions or comments, put them in there and I'll get them to Andy as we go along here.
Aside from the efficiency difference between spray and drip, another key difference is the application rates. Sometimes it's called precipitation rate, but how quickly is water applied. And without getting too technical, the flow in spray irrigation is measured in gallons per minute, and you'll typically have a runtime of your sprinkler system. It could be 8, 10, 12 minutes, something like that. In drip, we measure this in gallons per hour. It's a slower rate. Therefore, these systems end up running longer. Think 45, 60 minutes or more, depending on the variables that are in there. So this is another key to understand when we look at emission device basics with a drip irrigation system. We got to think in gallons per hour, not in gallons per minute. We adjust our run times accordingly.
Yeah, great point.
You can see the pictures below. We've got, you see a point source drip emitter, bottom left. We got an emitter line, bottom middle, and then some, these happen to be mini rotators, slightly more efficient than regular spray, but just an idea of these different styles. Before I get, further down the line of the drip, I want to touch on a key for all drip irrigation systems, and it is pressure regulation. Pressure regulation is important because these drip irrigation systems are not designed to run at the same pressures maybe that some of the spray irrigation systems run at. Typically, you do not want that pressure to exceed 50 psi. And if you have 90 psi coming in, you could blow your system apart. So by installing a pressure regulator, you can reduce the incoming water pressure. And a couple key things to remember there is that the flow rate of the pressure regulator should be matched with the system requirements. And it's a design principle of your incoming water's got to be able to keep up with the outflow, right? So that's a key there. And really having I've seen people try to do this without a pressure regulator, but when they do, they run the risk of weakening their system, and you really minimize the lifespan of the drip system, whereas you can maximize the lifespan of that system by installing a simple pressure regulator. Typically, these will be between maybe 15 and 50 psi. The key here is to match it with the flow. But 30, 35, 40 psi is very, very common in a drip irrigation environment.
So yeah, Andy, I think anybody who's installed drip without this and had a blowout as a result, some emitters blowing off or emitter line blowing off at a 90-degree elbow, you waste a lot of all that savings. It goes away pretty quickly when that happens.
Yeah, savings and extra labor and so forth and so on. But the key to remember here, the last key I'll mention is this is non-negotiable. You have to have a pressure regulator. Put it in.
Yeah.
And it's a cheap insurance policy. Another non-negotiable must-have in your irrigation system, drip irrigation system, is a filter. You can see here, this is a typical drip irrigation valve setup, valve filter regulator. The filter does exactly that. It keeps debris out of the irrigation line. Drip irrigation devices have much smaller orifices than a spray irrigation, where you can have small particles of sand could get through spray and it's not going to gum it up. In drip, that's not the case. So we put a filter on there to keep that debris from clogging up the line. The measurement for the filter is measured in micron or mesh. Mesh is the more common term, and 150 is the number you want to remember. 150 mesh. Most irrigation systems require 120 to 150. You go with the 150 mesh filter, and you will be safe, and that'll keep your system performing well. And I just put up here a little note, just a reminder from our webinar we did on filtration basics. Screen filters filter out sand and debris, seashells, things like that. A disc filter you would use if you had algae or organic material in your water.
Yeah, great reminder on that, on some of the basics of filters.
Okay, so narrowing it in a little bit more. We're kind of every slide we're going to narrow this down further and further. So here we are, drip, and there's two styles of drip. You have point source irrigation. This is the picture on the left. That is a typical example of point source irrigation. And then we have inline or emitter line, and that is a picture on the right. As you can see, that is a tube with an emitter built into it versus a tube with a emitter stuck at the end. We have a great presentation on our website that was called Point Source versus Inline, an entire webinar just dedicated to this subject. But for today's purposes, point source is appropriate when plant spacing is sparse and you want to get water right to the root zone of a specific plant. Emitter line is appropriate when you have dense plantings and you want to irrigate an entire soil area and plant plants wherever, or in narrow areas where other irrigation methods just wouldn't work. So just real key difference there between those two. But today for our focus, we're focusing on the left, is point source emission devices specifically.
So Andy, we've got a question coming in, and that is on spacing of inline. I think it comes in, the smallest, 6-inch, 12-inch, 24, even 36-inch. How do you know what the spacing should be?
Yeah, I toyed with putting this slide in here. I thought, well, I'd reference people back out to another webinar we have called Getting a Grip on Drip out on our website, where we get into this. And the simple answer is, what are the characteristics of your soil, the texture of your soil? If you have a heavy clay soil, and when you have a heavy clay soil, you get a water that moves this way. This is what's called capillary movement of water through the soil. You have gravitational water that moves down, a capillary that moves this way. And a heavy texture soil, you get a lot of water that moves sideways. And in a scenario like that, you can do 18 to 24-inch spacing between the emitter and between the actual rows. If you have a coarse sand where water it really narrow this way, but then kind of creates a channel, you want to go with a much tighter spacing, maybe 12 inches on the emitters and 12-inch on the laterals. I would say landscape scenarios, typical sandy loam or loamy sand, you would be good with a 12-inch spacing on the emitters in the emitter line, and then either a 12-inch or 18-inch spacing between the rows.
Okay, that's real helpful. Thank you.
But please check out the web. Another shameless plug for the website and the webinar on Getting a Grip on Drip. You may this slide actually may be in that one. There's a few where we've talked about this, but you can see the application rates between a point source system and an inline system are very similar. This is low flow. We're talking at max maybe 2 gallons per hour. Rather than the much higher flows in you see in spray. So this is really slow and low.
Andy, if I've got inline emitters like we see on the right-hand photo here, and I want to and then I've got a kind of a rogue plant off to the side, can I just pop a line in the inline emitter and run an emitter out to the rogue plant?
Well, I'm going to answer that question the best way I know how, and I'll tell you what I've done. Yes, I've done that. I've done that very thing in the past. Yes, the simple answer is yes, you can. I don't see a problem with that.
I guess the key would be there, Andy, is just to keep the gallons per hour at the same rate so that you're running, so that you know how much water you're actually applying.
Yeah, and I was gonna say that, and I got thinking, I've seen it with succulents before, where you just couldn't add another zone. We had let's say a 1 gallon per hour emitter line in a bed, and we ran a line over with a half gallon per hour emitter split two ways. So getting a quarter gallon per hour for some succulents were just, you really didn't like the wet feed. But yeah, typically you'd be right. You'd want to match that, like plant material. But I think understanding the hydrozone, the plant material, the water needs it has, and there's a little bit of leeway there, in my opinion.
Yeah. Okay. Great. It really depends.
Yeah,
On what you're watering and what you're using to water. But you're saying it's best just to be sure you match the same, that you match the rate to the plant.
I think that's the more important thing, match the rate to the plant.
Yeah.
In a perfect world, you'd have a separate valve for that, but that's not always the case. And understand the soil, understand the plant, the root depth of the plant, how much water it needs, and then you can, it's amazing irrigation. You said, the answer is it really depends. Well, there's a lot in irrigation that's black and white, but I think so much of irrigation is understanding principles. What are the core sound, scientifically proven principles? And once you have that base of knowledge, you'll then know where to apply those principles in a given scenario. And that's why education is so important, because we need to learn these principles and these fundamentals so that we can then make an educated decision in application.
Yeah. Okay.
All right. Another very, very key thing in irrigation, specifically drip irrigation, is a term called pressure compensation. Sometimes this is referred to as PC, and it's not political correctness. It is pressure compensation. So when you see an emitter that says PC, that's what it's referring to. And I want to make a blanket statement up front. I would say for 90 to 95% of landscape scenarios, I would recommend and I would use a pressure compensating emission device. And so this is important. Okay, now you're asking yourself, well, what is pressure compensation? Why is it so important? In essence, the pressure compensation feature of an emission device maintains a consistent flow from emitter to emitter, all up and down the line, regardless of the pressure differentials that exist. As water moves through tubing, the pressure is reduced due to friction loss. You could have at the beginning of a drip zone 50 psi. As it runs to plastic, and the tubing bends, maybe goes uphill a little bit. Anyway, it loses pressure, and it may only be 15 psi at the very end of the row. Well, without a pressure compensating emission device, you could have 5 gallons per hour flow at the beginning and half a gallon per hour flow at the end. And then you'll say, yeah, but the emitter says it's 2 gallons per hour. Well, that 2 gallons, if it's non-pressure compensating, if it's 2 gallons per hour, that is measured at a specific PSI, say 15 PSI. So higher than 15 PSI, the flow is higher. Lower than 15 PSI, the flow is lower. That becomes problematic when you're trying to manage irrigation and manage plant health. It's kind of the Goldilocks principle. At the beginning of the line, you're applying way too much water. At the end of the line, you're applying way too little. In the middle, it's just right. But way too little doesn't cut it. So what do? You apply just right at the end of the line, medium waste in the middle, and big waste at the beginning. And that's just not wasted water. It could be wasted fertilizer. It could be impacting the health of your plant material. Overwater plant material can cause sometimes as much damage as underwater. So the solution to all of this is pressure compensating emission devices. So regardless of my scenario, let's say from 15 to 50 psi, regardless of the friction loss of the water moving through the pipe, my output from emitter 1 through emitter 100 is going to be very consistent. That means improved health, plant health. It means less fertilizer is wasted. It means less water is wasted as well. It really simplifies your design too. So from a design standpoint, you have to worry about sometimes complex hydraulic calculations when you know that, hey, look, I can get this flow as long as my pressure is in this range and my flow is in this range. I can just put the emitters out there and I'm safe. And the other added benefit of pressure compensating emitters are that the diaphragm that's in there, the device that helps it maintain that pressure, also helps it from sucking sand in or getting otherwise plugged. So it's a longevity issue as well.
Yeah, I think that's a great point, Andy. This is a must-have, right? And many people don't even understand pressure compensation or if they're getting it or not. So, yeah, when you're installing a system, you really want to know if it's pressure compensating.
Yeah, yeah. If all this is way too technical, just remember one thing and one thing only: make sure it's PC. Make sure it's pressure compensating.
Yeah. So, Andy, we've got a question coming in, and it has to do a little bit with your preference, but somebody's asking here, I'm planning on setting up an inline system for veggies.
Mhm.
How much water per hour should I get, and how much space between dripping points and space between rows?
Okay, so my preference, and we have another shameless plug. We have a webinar called "How Do I Irrigate That?" and we did a section on vegetable beds. My preference is 1/4 inch emitter line, what we call mini pep line. Great product. I prefer the 6-inch spacing. You can use 12 if you had a heavier soil, but for me, where we typically have a sand, it's just amended with organic material. And my preference is to use that to irrigate the bed. And I like that. What we'll do is imagine a rectangle, right? At one end of the rectangle, we'll put a 1/2 inch piece of blank tubing where the water's coming in, and then we'll plug in that 1/4 inch emitter line and snake it back and forth, serpentine it back and forth along the bed, and then plug it back in at the other end. Lay it down into the bed. What that guarantees me, especially in a vegetable gardening where sometimes it's intensive in space, this old square foot gardening principle or concept, it allows you to plant anything you want anywhere, and it's guaranteed to get water. That's my personal preference. If you had hey, I got a 2 foot by 2 foot square and I'm only going to grow one tomato plant, you could probably get away with a couple point source emitters.
And Andy, what if, right? So I love that, especially for the raised bed gardens. But what if I've got a 1/4 acre? What if I'm gonna, really do some gardening, or I've got a bit more space than just the raised garden bed?
And just like in the picture behind you, those rows, you could use an emitter line or drip tape. And typically in agriculture, they're using a drip tape. That's an emitter spaced every 4, 6, 10, 12, 48 inches, depending on the crop, with a flow rate that is a lot lower than you typically would think. I mean, ag guys understand water movement through soil. They understand a slower application rate, you get more capillary action, and that's what they're doing. So you could use a drip tape or an emitter line in that scenario. And just remember, you don't have to have an emitter at every plant. You're not watering the plant, you're watering the soil. Fill the soil with water, let the plant grow in the soil. If you can remember that, you'll not get caught up on spacing so much. Spacing more pertains to soil characteristics, not plant density. And if you can remember that, you're irrigating the soil, you'll have a lot more success.
Okay, great. Thank you. I appreciate that input.
Yeah, no problem. Okay, so now we're going to jump into some specific emission devices. Most common that you'll see in a landscape scenario are these that are pictured here on the screen. This blue emitter up at the top left and the one in the middle, those are both button emitters. It's a very common style. The bottom kind of left picture you see as an octobubbler, we call it a manifold, kind of a different flow system. The yellow one we see there, we call that a flag emitter for obvious reasons. That is a non-pressure compensating emitter. Believe it or not, that little flag on the top comes apart. I guess you could clean it out that way, but that's one of those where depending on the pressure, your flow is going to change. And then on the right, we see these adjustable emitters, ones that come out in either a stream or they kind of bubble out. And we'll get into some of these, specifically when you might use these and what the uses can be for. I would assume that most homeowners probably have those ones on the right. I'm gonna try to convince you to use the ones the top left and middle. Hopefully, most contractors are using something the top left or middle. But we'll jump into those specifics here. First things first, these button emitters. I would say when we're talking point source irrigation, when we're talking kind of commercial irrigation. This is going to be the most common, and there's some real benefits to it. It allows you to get the water right to the root zone of the plants, and you can be very efficient with that. And there's a couple ways you can connect this. So you can see in this emitter here, maybe my cursor shows up. This right here, this button emitter, this is the emission device. Notice there's a barb right here. And this barb can either be punched straight into your distribution tubing, your supply line, or it can be connected, as you see down here in this picture, to a 1/4 inch supply line. Water comes in this way and comes out that way. And if this was turned, if you can see the bottom, you'd see a similar barb on that one right there. Like I said, you can connect it directly to your supply line, 1/2 inch, 3/4, 1 inch supply line, and then run 1/4 inch tubing from that to the plant, or you can do it the other way around. I'll show an illustration of that. Another key with these things, and you'll see that in these two emitters I've highlighted. On the left is a Jain click tip. On the right is a Turbo SC PC, which is a very common emitter. The one on the left is it's an enclosed emitter, very high end, very high quality emitter. The one on the right may not be as robust, but that cap screws off. So if that emitter did get plugged, you could take the cap off and flush it out and then screw it back on. What I learned as a landscaper is you spend more time and money cleaning the emitter off than it's worth when you can just cut one that's plugged off and put a new one in. So, and again, when it comes to this style of emitters, always choose pressure compensating. It's just make your life easy, choose pressure compensating, and you'll be happy. As far as some accessories that go with this, as you can see in this picture, it's not uncommon to have a locator stake, help hold that emitter in place, help hold it still. Sometimes either a plastic stake or maybe it's metal, just to kind of keep it where it needs to be down at the plant root zone. And as far as maintenance is concerned, the emitter itself shouldn't need much care if you have good filtration and good flushing. And we had another which is another topic entirely, but if you maintain those basic practices, good filtration and flushing, these emitters should last for many years. So here's the illustration with this point source emitter. I know the Irrigation Association, the IA, recommends this drawing A, where the emitter, and these are blurry, I apologize, the resolution is not very good, where the emitter is plugged straight into the supply line underground or covered under mulch, and then 1/4 inch tubing comes from that and brings the water to the plant. What's very common to see in the desert environments where emitters fail after 2 to 3 years because of hard water, and these lines are buried 8 to 10 inches under decorative gravel, is to see a 1/4 inch connector, the 1/4 inch tubing, and then the emitter daylight next to the plant. And so those are two common ways to pick your poison. My preference is C, this style here, but that is like I said, A is what you see a lot of recommendations from designers and other irrigation professionals.
So Andy, we've got another question coming in from a viewer, and that is, what's the best way to deter animals coming along and eating these emitter lines?
There's a HOA development just on the other side of the mountain from my house. It used to be called Askaya. They changed the name. When I was working for a landscape maintenance contractor, they had built the guard gate, clubhouse, everything. The economy took a downfall, and there was no houses. But they were just doing basic maintenance up there. And between the coyotes and the rabbits and the bighorn sheep, these things were just getting gnawed on. We never really found a solution. It's tough, especially when there's a drought and these animals are coming in, they're thirsty. They'll gnaw on these things. So you could, I know, guys, there was a company in Mesquite that was having problems with rabbits gnawing on the end of the emitter line. So they went back to burying this style A here, where they would bury the emitter and then have the line come up, and eventually the rabbits would just eat the quarter inch down to the nub, and they start digging down after it. So that's a tough one. It's like the question I got once. Hey, I like subsurface irrigation, but I've got all of these moles and gophers that chew through the lines. Do you make a gopher resistant line? And those are tough. Call an exterminator, I guess.
Yeah, I think you're right, though. I think the best way is to keep as much underground as possible. And if I had really bad issues, right, what about PVC with some type of a riser that you would add your emission device to? Sure, it's still going to get gnawed on eventually, but maybe less damage.
Yeah, I wish I would have had a picture for that. If it would have looked similar to this bottom right-hand corner here. Now, this isn't it exactly, but it looks similar to that. It was a 1/2 inch female pipe thread with a 1 or 2 gallon per hour emitter on the top of it. And that screws on to a PVC fitting, which is glued into either PVC or flexible PVC. And that, so you have a really like a hard pipe irrigation system, more expensive and harder to adjust as the landscape grows. But yeah, you could avoid some of those problems with animals.
Yeah, and I wonder if just some basic repellents that you can buy out there to keep animals out of your garden in general would help here too. Maybe like cayenne, or I know they put the hot peppers in the bird seeds. The birds can't taste it, but the squirrels can, and they don't like it.
Right. Yeah. Those work. Yeah, those work as well. It's, man, yeah, pest control. It's not my expertise, but.
Maybe a good subject for another webinar. That's for sure.
Yeah, there's all this talk about copper shield, copper and emitter lines to keep roots out. I'd like to see the gopher proof, the rabbit proof line, a chemical in there. But then I started thinking about it, extra chemicals and tubing and leaching into the soil, and it makes me a little bit leery as well. So I think there's some cultural practices. Not overwatering is probably one of them, and the way it's installed is another one. I think keeping things buried is key as well. And the next section I wanted to cover these manifold emitters. Now, these are not as common in the landscape, commercial landscape, but they do exist. You see them a little bit more frequently in residential. The world's leading and best, in my opinion, is the Octobubbler, an old Pepco product, now part of the Jain family of products. But as you can see, this is an 8-port irrigation device. It has a 1/2 inch female pipe thread. So in essence, you could remove a spray head, screw on an Octobubbler, and you now have drip irrigation. It is probably the simplest, most effective spray to drip conversion that's out there. Take the spray head off, screw this on, run your 1/4 inch tubing out to the plants, and voila, you have drip irrigation. This thing will come in flows from anywhere 2 to 20 gallons per hour. So you could kind of pick your poison. The one thing I think is great about the Octobubbler is it's pressure regulating and pressure compensating. It's the only one on the market that does that. Many of these, as you can see in the one I put in, the kind of looks like a tarantula with the X drawn through it. Those are non-pressure compensating. I have personal experience using those. I was at my brother's house, and he was getting ready for my niece's wedding out in the pool area. We had just planted a bunch of roses and stuff, and he had bought a bunch of these manifolds that were adjustable. And we put the first one on, got it adjusted just right. So the flow was just right for that plant, right? For that group of plants. Put the next one on, and as soon as we turned that one on and made adjustments to that one, it threw the first one off. And it was this constant balancing. As soon as you adjusted one, it threw the other off. And this is why pressure compensating matters, because in a pressure compensating system, that wouldn't happen. So you spend all this time making all these adjustments. and you're constantly chasing your tail when you could buy, a pressure compensating, pressure regulating device that alleviates all those problems. So just another plug for always choose PC.
Yeah, great example. I saw that one coming, and I thought, yeah, you're going to be constantly adjusting because the one is just always going to affect the other.
Yeah, it's great because you look at that and you think, oh, I can choose the flow I want. Well, in theory you can, but in practice, you're chasing your tail.
Yeah.
Chasing your tail. So. All right. The other emission devices, and I call these the other emission devices, although I'd guess a lot of homeowners and gardeners probably use a lot of these. These are non-pressure compensating emission devices. These are adjustable. So for example, you have the umbrella bubbler, which would be, and that can come with a spike. It can come with a 1/4-inch barb. It can come with a 10/32 thread to be used on a rigid riser. It can come with 1/2-inch female thread to be screwed straight onto a typical riser. But you get between an umbrella radius that sprays up to 2 feet or a shrubler radius that kind of just bubbles out, or streams like this, you get different applications of water. And these are adjustable, and you can adjust it from anywhere from completely closed up to 35 gallons per hour. Again, the problem is what you do to one affects the other. And it is not uncommon for these adjustable caps to go flying off, and then you have the fountains of Bellagio in your garden, and water is going on the wall instead of the plant, and then you're searching for a cap out there, and a black cap in your black mulch, and it becomes problematic. But these are common, and I will say I'm not saying there is never an application for these. If you had large pots and you're doing container gardening, you had a plant growing in a large pot, it could make sense to use a mini bubbler or a stream or this umbrella bubbler in a scenario like that. That could be a good application for it. These bubblers here are very common. Now this one happens to be adjustable. You can also get them fixed flow. The one place I see these used quite often, where I think they make a lot of sense, are palm trees, where you don't have like this massive far-reaching root systems. Typically the palm tree roots tend to be a little bit closer, and you can just flood the entire area and the roots are going to absorb it. So you could go with like your 4 or 5 gallon per hour, flood that, and it would make sense. So that could be a good application for these. These micro sprays like this, and also are not pressure compensating. The only time that I think that would make sense at all, when you're not wanting to use full on spray irrigation, what that micro application of water would be in succulents, along the coastline, where you're not really necessarily putting water to the root zone. You're putting water on top of the leaves and where they absorb it. That could make sense. So these are the exceptions. These are when the 95% of the time doesn't work, what options are there? These are these devices, and kind of some ideas of when and how you could use them.
Yeah, that's a great point, Andy. And one exception, I'll use a spray, for example, like you show here in the bottom left, when I'm growing plants from seed, and I don't want to grow them inside first into seedlings. And then once they get established, I'll cut off the spray and just go with the emitter line from then on out.
Great. Yeah, it's a great one. I hadn't thought of that. Yeah, starting from seed is great. And it has, get away from me. Sorry. It has the little adjustable, the Veriflow valve, you can turn it on or off just by turning that valve, and you can turn that off and do that. That's a great example too. I like that. The seed.
But you're right. As the pressure changes for whatever reasons, right? If you don't have a pressure reducer at the start, you're adjusting quite often.
Yeah. So again, this slide I stole from that webinar we did. How do I irrigate that? But I think it's a good reminder for emission devices, specifically point source drip irrigation. And it's where to put the emitters and how many do you use. I had once heard somebody say, well, look, it's simple. A 1 gallon plant, put 1 emitter on it. A 5 gallon plant, put 2 emitters on it. 15 gallon plant, put 3 emitters on it. and you'll be good. The problem with that is the same plant can come in 1, 5, and 15 gallons. So rather than following that rule of thumb, my recommendation is know the mature size of the plant, know where that root zone is, know what those water requirements are, and put the emitters to where the future growth of those that plant's going to be at maturity. It may a 15-gallon plant may only require 2 emitters. A 1-gallon plant may require 4, or 5. So understanding that becomes I think more critical than the size of the plant when you buy it.
Yeah, great recommendation.
Yeah. And then another concept here is hydrozoning. We touched on this a little bit earlier, but you can see in this illustration, you got trees, you got some grasses, you got a raised bed, you got a slope with shrubs, you got a lawn. Every zone, every plant type, every exposure, every soil has kind of a different water need. And the technical term we use for this is hydrozoning. And just to touch on it briefly, simple rule of thumb is this: keep your trees, all your trees should be on their own valve. Shrubs should be on a separate valve. Annual flowers or vegetables, shallow rooted plants should be on their own valve. If you just follow that simple breakdown for those 3, you could eliminate a lot of problems. If you wanted to get really into it, you could say sun versus shade, slope versus flat, sandy soil versus clay, and break it down even further. But just as simple as trees, shrubs, and flowers, annuals would, if you could keep those on separate valves. And the reason is it's about root depth. And remember, we're irrigating the soil to the depth of the root. If we go too shallow, it hurts the plant. Too deep, and we waste water. And if we're watering our flowers the same as watering the trees, we're going to underwater the one or overwater the other. And then lastly, just wanted to show some pictures of landscapes that are watered with a point source drip emission device. I hope every single one of these are pressure compensating. The landscape sure look beautiful. We're going to give the designers and the water managers here the benefit of the doubt and assume it's pressure compensating. Assume they're using great filtration. They're following all the good maintenance practices. Everything is hydrozoned, and because of that, they have a beautiful finished product that is not only beautiful, aesthetically pleasing, but is not wasting water like spray irrigation is. And so we can have beautiful landscapes, and we can be efficient. We can be wise with our use of water. We can conserve. We can, at this point in time, we can say we can have the best of both worlds. I think that's very doable.
Yeah, so this is a great example, Andy. I love that you show these, right? Because a lot of people think sparse plantings are the only way to be water wise. But again, a lot has to do with what you're watering with and getting it right. So these are great examples. We have another question here, and that's asking about what valves to use with drip irrigation. Does it matter?
Yeah, well, it does. Depending on the flow and pressure of your system, right? So typically with drip irrigation, you're using low flow and low pressure. And so you want to make sure you have a valve that can work in a low flow and low pressure environment. In commercial settings where sometimes you may be using a 1-inch valve with 1-inch distribution tubing, and you can still have a high flow and high pressure coming through it. But in some of these smaller kind of micro areas, a low flow, low pressure is going to be key for your valve.
Yeah, great point. Yeah, got to look for that low flow to maximize that system.
Yeah, and that's the information I had. If more questions, I'm happy to answer.
Yeah. So one, I just want to say thank you, Andy. You did a great job on this. And we do have one last question. We've got time for one last question. And certainly we've all learned a lot from this presentation. But someone wants to know if you've ever made subzones within a hydrozone.
Subzones in a hydrozone. Um, so when I think of hydrozone, I think it's broken down by valve. So I'm guessing a subzone and a hydrozone would be maybe, I've got plants growing in a similar exposure slope, similar rooted depth plants, but maybe some need more water than the other. And I'm going from maybe a 1 gallon per hour application to 2 gallon per hour application. I'm kind of adjusting that application rate. And that's what I understand from the question. The answer is yes. It goes back to that conversation earlier on, could you run a point source emitter off an emitter line setup and change the flow rate? I have seen that done when you have like a lone agave that you don't want to drown in water and end up with root rot. So you go with a slower flow. So yes would be the very qualified answer.
Yeah, no, you're right. I think, right. You definitely can. And certainly it comes down to the point source emitters is what you taught, and that makes it reasonable. And so I'm sorry, we do have one last question, Andy. You want to get this one answered? It's a good one, and that is, how do you plan drip line for a slope?
Drip line for a slope. Okay, so I like to run it not up and down, but left and right horizontally, right? A key to keep in mind, whether it's drip line or point source, is water is going to gravitationally move downhill. So typically, if you have a tree planted on that slope, and imagine that root ball is covering a large area, more water on the uphill side, more emitters on the uphill side than on the downhill side, because that water is going to move down. So keep it real simple. But I had a shrub that needed 3 emitters. Right, I'm gonna put 2 on the uphill side, 1 on the downhill side, because the 2 will move through. The other key is I want to make sure I'm using not only a pressure compensating emitter, but an emitter with a check valve, or CNL, closed non-leak. What that means is, water is going to sit in the line, and if at the top from the bottom, technical term is head, there's that pressure that's there, and if I don't have that check valve in, all the water is going to run out the lowest point. But with that check valve, that closed non-leak, it's going to hold the water in the line. That saves water. It creates wet spots and runoff. So that's going to be the other key, I think, on slopes for me. I think those things would be at least the 2 that come to mind immediately on the spot.
Yeah, no, I think I love the check valve idea, Andy. Thank you. That's a really helpful one. And again, Andy, thanks so much for doing this webinar for us today. I know we're all better equipped now to select the right emitters for our job. I want to thank all of you who spent a good portion of your day with us. We always appreciate that. We hope we're hitting the mark on our education. And please remember, you can see all our webinars at the Jain Irrigation. It's jainsusa.com/trainings. Or wherever you listen to your favorite podcast, right? We extract all the audio out of this, put it into a podcast too. And I love to see people out working and educating themselves at the same time. That's a great thing to see. So again, Andy, thanks so much for your time today. Really appreciate it. Thank you, everybody. We're going to be back here on Friday talking about some strategies for irrigation for pistachio trees. So should be interesting. So thanks again. Have a great day, everybody.
See y'all.